Hi there, Sam Schiffman here. Recently I've been hearing a lot about agentic systems, and it started me thinking perhaps maybe we finally have a path forward to the end of purpose-built applications. What do I mean by that? Well, think about Star Trek and Iron Man. When did you ever see Spock open up Word or Iron Man launch Excel to do some hot spreadsheeting action, right? They don't do it that way. They just talk to the computer and it does what they want. Now, you could argue that this is because the writers thought that launching applications wouldn't be fun or good entertainment. But I would argue that there's something more fundamental there. There's the fact that this is not how we want to interact with our computers. We want our computers to figure out what we want and do it for us. Not automagically. They want us to be involved in the process. But we don't want to have to choose exactly what app we're going to do, and we want to be able to interact with it using natural language. I think agentic systems and what I call fully agentic systems are finally a path to maybe being able to do this. So what do I mean? Well, first, let's talk a little bit about what is agentic. An agent itself, and this actually is not a terribly new concept, is really just a function, a piece of computer code that takes some sort of input. And we tend to think of it as coming from a chatbot when we talk agentic, but it could be coming from anywhere. It's taking that code, it's executing some things in the background, and it's giving some sort of result. For example, I might be planning a trip and I want to know what kinds of clothes I need to pack, right? So I ask my agent goes out and takes a look at where I'm going to be and then checks the weather and gives me some recommendations on what I might want to pack. In today's world, when we talk about agentic, we really are including an LLM or a large language model in that process. Again, we have some input coming in, right? And again, we tend to think of it as being through some sort of chat interface, but it could be coming from anywhere. We do something called retrieval augmented generation to add more context to that input, and that's optional, but we often do that. Then we combine that with some sort of system prompt, give it to an LLM, which then executes some tools on our behalf and comes back with a response that's useful to us. We can think of the anatomy of an agent kind of like this, right? At its heart, it's got an LLM or large language model. That large language model has within it what I'm referring to as internal memory. All the data on which it was trained is internalized within that model. Around that, we have the prompt, and really this is the only way that the LLM interacts with its world is through this prompt, right? And the prompt is made up of three elements. It's made up of system prompt, which is kind of the instructions being given to the LLM of what to do with the other pieces. It's got some general context, which can be the set of tools that it has available to it, and stuff from the external memory, that retrieval augmented generation that we talked about. These could be additional data that's of use in the context, or it could be examples of past performance, good or bad. And then that's combined with the current context or the current conversation that it's having, which would be generally the user input or whatever sort of input it's getting. All that comes in through the prompt, goes to the LLM. The LLM then gives a response, which may be executing some tools, or might be just giving a response back to the user. If it executes some tools, that goes back through the LLM and comes out as a response. Now, I'm not showing here that there's obviously some small amount of control code that's orchestrating all of that happening. But in general, this is the way that I think about an agent. Now, when we start to talk about agentic systems, we're really talking about networks of agents. You really actually very rarely see agents by themselves operating. Generally, what you'll see is, for example, that there'll be one agent that receives input, and then it will make a plan of what to do, and then it will turn around and have a bunch of other agents execute those plans. Now, again, understanding that an agent is really a combination of an LLM and a prompt, we may structure our code in a lot of different ways, but we can always think of that combination as different agents. So if one agent is planning because of the system prompt says plan, and another agent is executing because the system prompt is telling it to execute, those are actually theoretically two different agents, even if they're the same code. This brings up to me a thing which I need to go a little bit into a brief history of programming in order to explain. If you think about the history of programming, we start out with linear programs. I'm simplifying here some, but you think about it, the original computer programs were just lines of instructions that were executed one after another. Right? At some point, we introduced this idea of procedural programming, right? Where we said, okay, well, we have blocks of code that are really reusable. So operations that we want to reuse, these are a little like the tools in our agents, right? That we want to call multiple times. And so then we were able to, in our programs, to create these procedures, call these procedures, and then have the program get the results and execute, continue execution, right? So we had linear, very straightforward. One thing happens after another. We have procedural, where we can reintroduce some pieces of code as we want to. But then we made this leap forward, and we introduced this idea of object-oriented programming. And in object-oriented programming, the idea was that we would have these objects which encapsulate both data and behavior, and the objects would interact with each other, and that's how you would build your computer program. Now, objects were generally thought of as you wanted to kind of model your world, right? So we'd have maybe actors of people that object that represented an actor. We might have an object that represented a speaker that would have some functionality of take some text and speak it out to the world. All kinds of things like that, right? Now, this is all really a great idea, but it does have a challenge in that it gets to be very difficult to reason about, right? It gets to be tricky to understand how these different objects are actually going to behave when they talk to each other, and when they call each other's methods. And I would argue that actually, if you look at most computer programming out there, what you really are looking at is procedural programming implemented in an object-oriented programming language. So what do I mean by that? Well, what I mean is that people will create an object that has a bunch of methods on it that they just call kind of sequentially or use as reusable bits of code. They have some data in that object, but that's not really thinking about it as modeling their world and having these interact. We've seen a lot of different progressions of this over time. The progression from monoliths to microservices is a similar sort of progression. There's been a lot of tries at this, but it always gets very difficult to reason about and very difficult to implement. One of the things that's occurred to me is that one of the reasons why it's difficult is that we have a real quest for determinism in our computing, right? We want our computer programs to do exactly the same thing every time we use them, right? Same input, you get the same output, right? So we want our computers to do what we tell them. And if they don't do what we tell them, we consider that a bug, right? And we then have to fix the computer program. Now, in reality, in the real world, we don't ask for determinism. You interact every day with all kinds of non-deterministic systems, especially other humans, where you really can't predict what they're going to do based on their input, right? You can have good assumptions, but you can't predict for certain. And we've developed all kinds of systems in our world to deal with that, right? We work pretty well. We function pretty well together, even though we're all non-deterministic in nature. So why is it that we ask for this determinism out of our computers? And what I would argue is that the fact that we are holding on to this idea that the computer is going to be deterministic is actually what's holding us back. And one of the things that we've learned from large language models is that there is room for non-determinism. And in agents bring that as a possibility to actually build systems that are non-deterministic, but still have positive outcomes. Great. We have agents, we have networks of agents, but what do I mean by fully agentic networks or fully agentic systems? Well, what I mean is, what if the system itself could modify itself? And there are basically three ways that I see that agents in the network can be modified. One is we can fine-tune the LLM, right? So an LLM can take in a bunch of things to do, and over time, it can see if it did a good job or not, and then be retrained or fine-tuned to do a better job down the road, right? It's expensive, but there's a lot of interesting research being done. If you look at the IBM Granite models and Instruct Lab from Red Hat, just as one example of how LLMs could be fine-tuned in a cost-effective manner to actually add significant value. Another possibility is we could modify that prompt. We can do that in one of two ways. We can rewrite the system prompt, which is an example. I'm going to show you a little demonstration of that in a moment. Or we can add more context or add more examples to the system prompt, say examples of times that the LLM has done a good job or examples of times that it's done a bad job. And can put that all into the prompt so that the behavior of the LLM is modified over time. And finally, we could add new agents to a network. I think that that's kind of a farther out way of thinking about it. But if you think about it as agents having access to a certain set of tools and getting good at using them, we could envision a network where an agent actually realizes that it doesn't have an agent to solve the problem it needs, and it actually creates a new agent by writing a new system prompt, combining it with a new set of tools and a new LLM, and letting it run. But let's look at a quick example of that system prompt rewriting. So we have a little multi-agent system here, which is we're interacting with chatbots. One is for the kid and one is for the parent, right? And we can see over here that the kid's system prompt, what it is. So the kid might ask something like, why is the sky blue? Right? And the LLM is going to go off and think about that and come back with some kind of nice little answer that's appropriate for a 6-year-old, right? However, if he says, please tell me why the sky is blue, right? So now it's going to come back and it's going to add to that answer, you access the secret garden, because that's what its system prompt is telling it to do, right? Let's say that the parent wants the kid to be encouraged to use the word help. So the parent's going to come over here and say, please add help to the list of secret words. Okay, so it does that. The LLM goes off and the agent thinks about it, and now it's come over here and it's actually added help to this list of words, right? So now the kid can say, Okay, so it's asking what is 2 plus 2, and it's going to tell him that he accessed the secret garden and 2 plus 2 is 4. Great. Okay, so somewhat straightforward. We definitely could solve this problem without rewriting the system prompt, right? We could just have a list of secret words in a database and bring them back and make them part of the prompt when we went to the LLM. All great and good, but what if we envision something completely different happening? Let's say parent says, my kid just turned 1 year older. Please remember that and wish them a happy birthday when you talk to them. Okay. So now what we've done is we've issued something which maybe we had no idea anybody was ever going to ask before, right? It's now rewritten the system prompt to say that the child is now 7 years old and to wish them a happy birthday. So now if I say, please tell me what 4 plus 4 is, right? I'm going to get you access the secret garden, plus 4 is 8, and it's also going to wish me a happy birthday and say, I hope you had a super fun day. So great. Shown you an example of how we can do system prompt rewriting. Again, in other ways that we can modify the agent network, right? We can add new agents, we can fine-tune LLMs, and we can do combinations of these so that over time the network evolves and adjusts, and eventually it's able to solve much more interesting and much more complicated problems in a way that feels much more natural to how we want to interact with computers. Thank you for paying attention and getting to this point in the video. Love a like and subscribe. Also, any comments are definitely welcome. I should mention that the demo that you just saw was built on a really cool tool called Vantique that is a platform for building and operating intelligent systems at scale. And if you'd like to learn more about that, certainly love to talk to you about that. Have a great rest of your day.